So we are continuing in the tomorrow session of your class. If intensities of both of them are becoming same data, resultant intensity formula is what? IR is equals to your I1 plus I2 plus 2 into root of your I1 into your I2 into cos phi. If I1 and I are same, I1 is I, I2 is also I, plus this is 2. This will become how much for me? But root of your I square will become how much for me? Root of this one will become for me 2I into your cos of your phi. This value will become for me 2I plus of your 2I into your cos of your phi. This one I can take 2I common into this is 1 plus of your cos phi. And you know this formula 1 plus of your cos theta is equals to 2 into cos square theta divided by 2. So this can be written as of your 2I into this one is right now for me 2 into cos square phi divided by 2. 2 into 2, this will become for me 4. So it is a 4 into your I into your cos square phi divided by 2. So this will be the resultant intensity. Very important formula to be remembered. If intensities are same, the resultant intensity can be written as of your IR is equals to 4I into your cos square phi divided by your 2. Am I clear?
Yes.
Am I clear?
Yes.
Okay. So tell me phi is equals to 0, what happens? If phi is equals to 0, that means for central maxima, resultant intensity will become how much for me? IR is equals to 4 into I into your cos square. Phi value is 0. 0 divided by 0 is 0. Cos 0 is nothing but equal to 1. So I resultant will become how much for me? 4 times of your I. Intensity is equals to 4 times into I at your central maxima. Am I clear?
Yes.
Sure. The next one and very important experiment. Proof of your wave nature. It is your Young's double slit experiment. Young's double slit experiment. Also called as of your YDSC. This is an experiment which is being used for the proving the wave nature of your light, whether the light is of a wave or a particle nature. This basic phenomenon is being used for that. But that is YDSC, very, very important for the what you call that one NEET examination. Very important area. One of the very important area in the wave optics is YDSC. Okay, it proves for me wave nature of your light. And right here, it proves your wave nature of your light. Sure. I'm drawing the experimental setup bit after this one. There is a slit here, bit somewhere here. Okay. And there is one more slit somewhere here. Okay. And there is a small hole in between them. Here I'm taking a small hole. Sorry. So I'm taking one small hole here and one small hole here. Thus, this is your central maximum. This. Okay. Just draw the line for this one. This one. Okay. This is acting as of your one source S1. And here there is another source. And here there is your parent source. on the parent source, the light is going in all the directions like this. Here it is not possible to go, so it will stop here. This all light rays which have been incident on this one, this has been blocking. Only this rays will be going right now from here. So some of the rays will be meeting at the center like this. And this some of the rays will be meeting exactly at the center. This is called as of your central maximum. This will be your white part. And some of the rays will be directly going like this and meeting somewhere here on the screen. And here also one of the ray will be meeting and going to meet somewhere here. Okay. So from this one, if I drop a perpendicular somewhere here, this one is very important beta. This is your perpendicular. This angle is right now with this one, making an angle of your 90 degrees. An angle made by this one is right now here, small angle, that is nothing but theta. The distance between the slit and the screen is right now for me capital D. This one is known as of your screen, and this one is known as of your slit. Okay, S1 and S2 are two monochromatic source. So this is called as of your slit. And here see the distance between these two is right now for me D. This is your small d. Okay. And somewhere here we are getting some point. So that one I'm giving a name, say for example, Y. Okay. And here see capital D is much, much greater than small d. Am I clear with experimental setup? So experimental setup IDSC consists of what? Slits. S1 and S2 are acting as of your monochromatic source of lights beta. And this one is called as of your screen. The distance between the screen and slit is capital D. Small d is the distance between the two sources, S1 and as well as of your S2. So I'll write here, small d is equals to, this is your separation between slits. Am I clear? And capital D is equals to, this is your distance between, slit and screen. Slit and as well as of your screen. Now path difference is right now for me this one bit. The point of this point, whatever I'm taking right now. So this is your S1, this is your S2. This one I'm taking some point of your P. Am I clear? Am I clear?
Yes, sir.
Now what is the path difference beta? This distance will be acting as of your path difference. That is nothing but delta x. Now see this wave when it is been going, this is the distance traveled by the wave and which is reaching somewhere at a point of your P. Another wave has been traveling somewhat extra distance. You see here right now. This is your extra distance which it has been traveling. So that extra distance only we are calling it as a what? Path difference. So this is your path difference. This one. That I'm writing it as of your delta x. Now how to write the value of delta x beta? So path difference, if I'm writing here, path difference. Delta x will be equal to, which one is larger you are able to see beta in this one beta? So if I'm taking the source, this one is your source of the light S. From the larger distance, if you see from the diagram, it is S, S2 into P minus this one is S, S1 into P. Am I clear with this one? This is your larger distance, S1, S, S2 and your P. Am I clear? Minus of your S, S1 into P. That will be your path difference. If I'm writing SS2 beta, SS2 will be equal to how much beta distance? It will be S, S2 plus of your S2P, isn't it? Minus, then this one will be S1 plus, this will be your S1P. Okay, and you know that this S1 and SS1, S2 will be same. So this two will get cancelled. This one and this one will get cancelled. If both of them are getting cancelled, we are getting the path difference. Delta x will be equal to how much for me? S2P minus of your S1P. Okay. So this value will be equal to, I'm giving some name here right now, say for example, capital M. So this value will be equal to your S2M is your path difference. Am I clear? So delta x will be equal to S2P minus S1P. That difference is equals to this distance beta. This distance will be equal to your S2 into M. Okay. S2 into your M. This distance is D, but see, you know in vectors, if this is a distance D and this is making an angle theta, this is a perpendicular distance. This is your theta, this is your D. This value will become for me D cos theta, and this value will become for me D sin theta. That means this S2 and M will be equal to how much beta? D. How much? Delta x will be equal to D into your sin theta. When theta is larger, then delta x is equals to D into sin theta. If theta is very smaller, Okay. If theta is very small, like 0 degree, 3 degree, 4 degree, 5 degree, then sine theta will be approximated to your tan theta beta. So in that case, I'll be writing delta x will be equal to d into your tan theta. In general, for doing problems, we'll be using delta x is equals to d into tan theta. Now from the given figure, if you see better, what is the value of your tan theta? If I drop a perpendicular from this one, from the central part, this is making an angle of your theta. From the figure better, from this central point, this one S and this one is right now for me some distance. From the C from the figure, this value can be written as right now for me. Anyone? If I'm giving naming for this one, say for example, this is your A, this is your P, and this is your center. From your triangle ACP, from a triangle ACP, tan theta will be equal to how much beta? Perpendicular divided by base. So I can write delta x will be equal to how much for me? Delta x is equals to, like say if this is a triangle like now for you, like this. This is your theta, this is your y, this is your d. So from the given figure, tan theta will be equal to perpendicular divided by base. That is y by d, isn't it? So this will become for me d. So tan theta will be y divided by capital D. So delta x is equals to y d into y divided by capital D. So this is our basic formula for your path difference. Very important. Am I clear? Am I clear?
Yes, sir.
So what is the path difference formula right now for me? Path difference will be equal to delta x is equals to your d into tan theta. Tan theta is y divided by capital D. That is your tan theta formula. Path difference is equals to your dy divided by your capital D. Now you need to by heart this one, but you need to by heart or commit it to memory. Learn it by heart. इसको याद रखना, एवरी टाइम डिराइव कर लेते हुए नहीं बैठ सकते हम लोग. सो पाथ डिफरेंस इज इक्वल्स टू d into y divided by capital D. Small d is the distance between the slits. Y is the point where the constructive or destructive interference will happen. And capital D is the distance between the screen and as well as of your slit. Am I clear? I've already written the points here. I'll write here y again. What do you mean by y? Y is equals to, it is your distance of point P. Distance of your point P from central maximum. From your central maximum. Am I clear? Sure.
Yes.
Next one. Now see for constructive interference. For constructive interference. Constructive interference means bright point. For your bright point, constructive interference. That is for your bright point or maxima, we can say. This is also represented right now for me, maxima. I told you yesterday for maxima, minima, what is the path difference formula, beta? For maxima, delta x will be equal to n into lambda. N value will be equal to 0, 1, 2, 3, 4, go on like that one I told you. Isn't it? Now, what is the delta x beta for the constructive interference? It is small d into y divided by capital D is equals to n into lambda. So, what is the value of your y here? Y is equals to n into lambda into capital D divided by your small d. So, this is your position of your y. Y is equals to n into lambda into capital D divided by small d. Okay. So, this y will represent me the position of maxima. This will represent me what? The position of your maximum. Now see in this one, if I take n is equals to 0, if n is equals to 0, y is equals to 0. If y is equals to 0 means we'll be getting what beta? Central maxima. That means the point where the path difference or the phase difference is how much? 0. Delta x is equals to 0 and delta phi is also equal to 0. Okay, na? If n is equals to 0. If I take n is equals to 1, first bright point, where the first bright point will get? Y is equals to lambda into capital D divided by small d. This is your first maxima on the screen. First maxima on the screen. In the same way, if I'm taking n is equals to 2, then y is equals to your 2 lambda into capital D divided by small d. This will be your second maxima. Am I clear? So like that, if I go on take the relation right now for me, then if I take for nth part, y nth maxima is equals to n into lambda into capital D divided by small d. This is your y nth maxima. Okay, so this is the formula for your y nth maximum. Okay, on the screen, where do we get the first maximum? Means this diagram you need to remember in the given condition. Okay, so y is equals to your n into lambda into capital D divided by small d. What is capital D beta? Distance between screen and slit. What is small d? Distance between the slits. Am I clear? And what is the y? Y is the right now for me what? Distance of the point P from the central screen. Am I clear? Sure. Now, once I know the maxima, can I write about destructive interference? For destructive interference. For your destructive interference. That means it is your dark point. Dark point, or we can also say this one will be your minima. So for your destructive interference or for your dark point. For your dark point. So for dark point, what is the path difference I told you? Delta x is equals to your 2n minus 1 into your lambda divided by 2. Isn't it? What is delta x beta? Delta x is equals to y into your d into y divided by capital D. That is equals to 2n minus 1 into lambda divided by 2. So from this one, if I write y is equals to your 2n minus 1 into lambda into capital D divided by 2 times of your small d. Am I clear? So this is your y position. Am I clear? So y will be representing me what? It is your position of minima. Where is the first minima? Where is the second minimum? Yes, you can use this formula. And you know that in this one, n value starts from where beta? 1, 2, 3, 4, go on. In this case, if I'm taking n is equals to 1, then where we get the first minimum? Y is equals to n is equals to 1, 2 into 1 is 2, 2 minus 1 is 1. So it is lambda into capital D divided by your 2d. This is your first minimum. This is your first minimum. The same way, if I take n is equals to 2, then y is equals to 2 into 2 is 4. 4 minus 1 is 3. So it is 3 lambda into capital D divided by 2 times of your small d. So this will be your second minimum. Okay. From where lambda is nothing but wavelength of the light used. Lambda is nothing but your wavelength of light used. Wavelength of your light used. Okay. The same way, n is equals to 3 if I'm using. Y is equals to 2, 3 is 6, 6 minus 1 is 5. So it is 5 lambda into capital D divided by 2d. This is your third minimum. Okay. So like that, if I'm going on taking for the given condition, for n is equals to n, we'll get y nth dark. Y nth dark will be equal to how much per mu? 2n minus 1 into lambda into capital D divided by 2 times of your small d. So this will be the position. Okay, for nth, this will be the form. Y nth will be equal to your this one. 2n minus 1 into lambda into capital D divided by your small d. Any problem in these two formulas, beta? Y nth and y minima. This will represent me the position of your minima. Y nth minima will be equal to 2n minus 1 into lambda into capital D divided by your small d. Am I clear?
Yes, sir.
Sure. So if I redraw this diagram, once to understand you. So
That,
is better.
that
Yeah, tell
YDAC
me.
में YDAC है ऊपर आप जो लिखा है ना सर YDAC
जी
उसमें डेल्टा एक्स फॉर्मूला है ना सर पार्ट डिफरेंस का
पाथ डिफरेंस का
फॉर्मूला है सर,
हाँ,
उसमें m का मतलब सर,
एन इज नंबर बेटा, इंटीजर है, एन
m
इज योर
m
इंटीजर। हाँ
m सर, YDSC में बोले,
हाँ
YDSC में
हाँ,
उसमें लिखा हुआ है ना सर, S2 इंटू पी माइनस S1 इंटू पी इक्वल टू S2m।
ये वाला।
हाँ सर, S2m का मतलब, m का
तो
मतलब सर,
यहाँ देखो, एस इज सोर्स, एस मतलब सोर्स ऑफ लाइट, एस
ओके
वन मतलब ये जो स्लिट होल बनाया हो ना, इसको बोलते हैं एस टू इज नथिंग बट ऑफ योर, इस स्लिट का जो होल है ना, इसको एस टू बोलते हैं, सोर्स, सेकेंडरी सोर्स। एस वन एंड एस टू आर द सेकेंडरी सोर्सेस, एस इज योर पेरेंट सोर्स, ठीक है ना?
अच्छा, m का मतलब सर, m
क्या बोले?
m का मतलब सर,
एम इज नथिंग बट सम पोजीशन, सम पॉइंट दिया बस,
अच्छा
जैसे पॉइंट पी दे रखा है ना, वैसा एम। सो एस टू टू एस
अच्छा
टू एम विल बी रिप्रेजेंटिंग द पाथ डिफरेंस डेल्टा एक्स,
अच्छा,
ठीक है?
हाँ सर, ठीक है सर,
दिस
जी
इज
सर,
योर डेल्टा
थैंक,
एक्स। चलो, so this is your YDSC का formula. Now, if I take one more shape, and if I'm keeping somewhere here, this one. Okay, and if I'm taking small holes here, and even here go. And this one is right now for me what beta? Capital D. इसको हम लोग क्या बोलते हैं बोला मैंने? स्क्रीन। ये हो गया सोर्स S1, ये हो गया सोर्स S2, और ये हो गया पेरेंट सोर्स S। द रे ऑफ लाइट जब इसमें से ऐसा जा रही है यहाँ पर गिरेगा, इसमें से जब ऐसा जा रही है यहाँ पर गिरेगा, isn't it? तो सेंटर का ये जो था ना, ये तो था सेंट्रल मैक्सिमा, okay? Then if I'm talking about the given condition here, ये दो फर्स्ट मैक्सिमा अगर मैं बात कर रहा हूँ, यहाँ पर अगर कहीं पर पड़ा होगा, इसलिए तो जितना ऊपर पड़ेगा उतना नीचे भी पड़ेगा इसी तरह से, isn't it? So this is your S1, this is your S2, ये हो गया स्मॉल d, S1 S2 के बीच में डिस्टेंस हो गया स्मॉल d, दिस इज द सोर्स, ठीक है? सेंटर पे क्या पड़ेगा अपने को? सेंट्रल मैक्सिमा। यहाँ पर क्या है अपने पास? सेंटर के बाद हम लोग क्या पड़ेगा? मैक्सिमम पॉइंट पड़ेगा, उसको हम लोग बोल रहे हैं सेंट्रल मैक्सिमा, ठीक है? फर्स्ट मैक्सिमा यहाँ पर कहीं पर गिर रही है, दिस इज योर फर्स्ट मैक्सिमा, फर्स्ट मैक्सिमा। फिर नीचे भी पड़ेगी एक, दिस विल बी योर फर्स्ट मैक्सिमा, ऊपर नीचे सेम पड़ेगा, ठीक है ना? So this one will be equal to your second maximum, and here will be equal to your second maximum, ठीक है? तो इसको मैं यहाँ पर ही निकाल देता हूँ, इसको रीड्रॉ अगर मैं कर रहा हूँ, तो फर्स्ट के लिए अगर ड्रॉ कर रहा हूँ इसको देखो, सो दिस विल बी समवेयर हियर, फर्स्ट के लिए, ठीक है ना? उसी तरह से और एक वाला यहाँ से अगर ले रहा हूँ फर्स्ट के पास, तो दिस वन, ठीक है? दिस मेक एन एंगल थीटा, सो दिस आल्सो मेक्स एन एंगल थीटा। तो जितने ऊपर मैक्सिमा पड़ रहे हैं, वट एवर द नंबर ऑफ मैक्सिमा इज अबव, द सेम विल बी द बिलो, समझ क्लियर? एट द सेंटर y value will be equal to 0, isn't it? For the first maxima, what is the value of y beta? For the first maxima, y value will be equal to, can you tell me what is the y value? First maxima, y is equals to your lambda into, कितना होगा बेटा? कैपिटल D डिवाइडेड बाय स्मॉल d, इसके लिए भी उतना है, y is equals to lambda कैपिटल D डिवाइडेड बाय स्मॉल d। फर्स्ट मिनिमा इसके बीच में पड़ रहा है बेटा, दिस इज योर फर्स्ट मिनिमा, फर्स्ट मैक्सिमा सेंट्रल मैक्सिमा के बीच में, एंड दिस वन इज आल्सो योर फर्स्ट मिनिमा। फर्स्ट मिनिमा की वैल्यू कितनी है बताओ? वाइज इसकी आधी रहना चाहिए, यानी y इज इक्वल्स टू लैम्बडा कैपिटल D डिवाइडेड बाई 2D। इसके लिए भी उतना ही, y इज इक्वल्स टू लैम्बडा कैपिटल D डिवाइडेड बाई 2D फर्स्ट मिनिमा के लिए। याद है ना? देखो फर्स्ट मिनिमा के लिए कितना लिखा था, देखो फर्स्ट मिनिमा के लिए, फर्स्ट मिनिमा y इज इक्वल्स टू लैम्बडा इंटू कैपिटल D डिवाइडेड बाई 2D, यानी फर्स्ट मैक्सिमा का हाफ है ना बेटा। फर्स्ट मैक्सिमा कितना है, लैम्बडा D बाई स्मॉल d है, ये कितना है, लैम्बडा D बाई 2D है, तो उसका आधा यानी उन दोनों के बीच में रहेगा। फर्स्ट मिनिमा इज इन बिटवीन द फर्स्ट मैक्सिमा एंड द सेंट्रल मैक्सिमा। समझ लिया?
Yes.
अच्छा, अब ये जो दोनों के बीच में की जो डिस्टेंस है बेटा, देखो दिस इज योर सेंट्रल मैक्सिमा और ये हो गया फर्स्ट मैक्सिमा। The distance between the central maxima and the first maxima is known as of your fringe width represented by beta। या इसके समझे, सेकंड मैक्सिमा या फर्स्ट मैक्सिमा के बीच में का जो डिस्टेंस होता है दैट इज रिप्रेजेंटेड बाय बीटा। बीटा इज नोन एज ऑफ योर फ्रिंज विड्थ। इट इज नोन एज व्हाट फॉर योर फ्रिंज विड्थ। समझ लिया? फ्रिंज विड्थ का फॉर्मूला क्या है, याद है आपको? फ्रिंज विड्थ इज वेरी इंपॉर्टेंट फॉर्मूला, बीटा इज इक्वल्स टू लैम्बडा इनटू कैपिटल D डिवाइडेड बाय स्मॉल d। याद रखो, fringe width is the distance between two maxima or two minima. Two maxima or two minima. Beta is equals to lambda into capital D divided by your small d. Small d क्या है बेटा? Small d is the distance between S1 and S2. Capital D is the distance between the slit and screen. ये हो गया मेरे पास slit और ये हो गया screen, दोनों के बीच के distance capital D. Am I clear?
Yes.
Next one is your very important formula, angular fringe width. Angular fringe width. Okay, angular fringe width यानी theta. So theta value will be equal to how much for me beta? Fringe width divided by beta. Fringe width divided by distance between slit and screen. Slit and screen. यानी I can write here theta will be equal to fringe width beta divided by capital D. So theta is equals to beta divided by capital D. Yeah, I can even write beta will be equal to your D into your theta भी लिख सकते हो। Fringe width is also equal to capital D multiplied by theta. Am I clear?
Yes.
Now, if someone asks you what is the shape of fringe width, what is the shape of your fringes? Shape of the fringes is always hyperbolic, but it will be your hyperbolic, यानी ऐसा कुछ होगा। ये सेंट्रल मैक्सिमा होगा ना, तो शेप्स जो बनेंगे ना इस पे ऐसा कुछ बनेंगे, ऐसा ऊपर और उसी तरह से नीचे ऐसा। सो ये होगा शेप्स। दिस आर योर, okay, so what is the shape of the fringes? If someone asks you what is your answer, shape of your fringes will be equal to how much for me? Hyperbolic. Am I clear? Am I clear?
Yes, sir.
Okay, so angular fringe width का फॉर्मूला क्या है? Theta is equals to beta divided by capital D, or beta is equals to D into lambda. Okay, this formula is applicable when YDSE is in air. YDSE is in air. If YDSE is immersed in water, then what will be the condition? Here it is very important. If Young's double slit experiment is done in water or any liquid, then at a time the fringe width will change. Fringe width will be beta dash will be equal to your beta divided by lambda or refractive index mu, because you know the diffractive index mu is equals to lambda divided by lambda dash. Beta dash will be equal to, what is the formula I can write here? Beta dash will be equal to lambda dash capital D divided by small d. Capital D change नहीं होगा, small d will not change, only lambda dash will change. So lambda dash can be written as of your lambda divided by mu. So I can write here beta dash will be equal to lambda into capital D divided by mu times of small d. So lambda into capital D divided by small d can be written as of your beta divided by mu, because beta का formula क्या है? Lambda into capital D. So whenever it is immersed in water, new fringe width will be equal to original fringe width in your air divided by refractive index of your liquid. Okay, so mu is equals to your refractive index of liquid. Refractive index of your liquid. सो एक्चुअली रिफ्रैक्टिव इंडेक्स क्या होता है? स्पीड ऑफ लाइट इन वैक्यूम डिवाइडेड बाय स्पीड ऑफ लाइट इन योर मीडियम, और लैम्बडा डिवाइडेड बाय लैम्बडा डैश. म्यू इज इक्वल्स टू सी ऑफ योर सी डिवाइडेड बाय वी. ठीक है, दिस इज योर रिफ्रैक्टिव इंडेक्स इन ऑप्टिक्स. समझ लिया?
Yes, sir.
क्या समझ में आया? अगर यंग्स डबल स्लिट एक्सपेरिमेंट हम लोग वाटर में कर रहे हैं, तो जब उसका फ्रिंज विड्थ कितना हो जाएगा? फ्रिंज विड्थ जितना एयर में था, एयर में कितना आया था मेरे पास? देखो यहाँ पर लैम्बडा डी डिवाइडेड बाय स्मॉल डी. ये देखो लैम्बडा डिवाइडेड बाय स्मॉल डी कैन बी रिटन एज व्हाट? बीटा. और ये म्यू एज इट इज है, तो बीटा बाय म्यू हो जाएगा. So whenever it is immersed in water, the new fringe width will be equal to fringe width of the air में जितना भी होगा उसको डिवाइड करो by the refractive index. That will give me the new fringe width in the liquid. समझ लिया?
Yes.
चलो ये क्वेश्चन कर लेते हैं, so we'll get an idea. See, in an YDS, the fringes are formed at a distance of 1 meter. Are formed at a distance of 1 meter from double slit of separation, 0.12 mm. Okay, calculate the wavelength of light used. Calculate the wavelength of light used. Its distance of third bright band from center of screen is 1.5 centimeters. Okay, so options are given for me: 6,000 angstroms, 5,000 angstroms, 8,000 angstroms, and 4,000 angstroms. पहले क्वेश्चन को पढ़ो. Read the question. In a YDSC, the fringes are being formed at a distance. Fringes are being formed at a distance of your how much for me? 1 meter. यानी capital D is equals to how much for me? 1 meter. From double slit separation of 0.012 mm. यानी small d. Small d का distance कितना है? 0.12 mm. Okay. Let's calculate the wavelength of light used if the distance of third bright band from the center of the screen is, यानी third fringe width is equals to 1.5 centimeters. यानी this will be 3. बीटा का फॉर्मूला क्या है बेटा? लैम्बडा इंटू कैपिटल डी डिवाइडेड बाय स्मॉल डी, दैट इज इक्वल्स टू 1.5 सेंटीमीटर, मतलब मीटर में लिख रहे हो तो इट विल बी 10⁻². तो अपने को निकालना क्या है? वेवलेंथ निकालना है. So wavelength lambda will be equal to 1.5 into 10⁻² into your small d divided by, this one is a 3 into your capital D. So it is equals to 1.5 into 10⁻² into small d is 0.12 mm. 1 mm will be equal to 10⁻³ divided by 3 into capital D. Capital D is in meters, तो meters में रख दो, कोई प्रॉब्लम नहीं है. इसको भी हम लोग meters में आ गए. ये मीटर will get cancelled right now for me. ओके ना. 1.5 मतलब कितना हो जाएगा बेटा? 3/2 हो जाएगा. सो 3/2 हो जाएगा. दिस वन इज राइट नाउ फॉर मी 3 डिवाइडेड बाई 2 into 10⁻⁵ into 0.12 into 10⁻³ divided by your, this one is 3. A3 will get cancelled. 2 ones are, this is 0.6. आया? 1/2 is nothing but of your 0.5 भी लिख सकते हैं otherwise. Am I clear? So this value will be equal to 0.6 into, this one is 10⁻⁵ and this will be 10⁻⁻3. Am I clear? और कुछ है क्या?
Yes.
This is 10⁻⁵ का है, -2 है ना बेटा, सॉरी. 1.5 into 10⁻⁻2 है ये. So this one is 10⁻⁻2 है. So this is 10⁻⁻2, यानी 0.6 10⁻⁻2 -3. Clear?
10 power minus 5.
कितना आ रहा है?
0.6 into 10 power minus 5.
0.6 into 10 power minus 5, isn't it? And this value will become how much for me? 6 by 10. This value will become for me 6 into 10 power minus 6. Minus 6 नहीं, minus 4 होता शायद ना? कैलकुलेशन मिस्टेक जा रहा है क्या देखो आप. चलो एक बार देख लो एक बार. This is 3 by 2 into this is 10 power minus 2 into 0.12 into 10 power minus 3 divided by ये हो गया 3. A3 will get cancelled. 1 by 2 is 0.5. 0.5 into 10 power minus 2 into 0.12 into 10 power minus 3. Am I clear? तो ये हो गया 0.5 मतलब this will become for me 0.06. So this will be 10 power minus 2 into 0.06 into 10 power minus 3. तो ये बन गया मेरे पास 0.06 into 10 power minus 2 minus 3. So this will be 0.06 into 10 power minus 5. 0.06 मतलब 6 divided by your 100 into 10 power minus 5. है ना? Am I clear? So this value will become for me 6 into 10 power minus 5. This will be minus 2. This will be equal to 6 into 10 power 5, 6, 7. This will be equal to minus 7. Okay. So अगर मैं इसको approximately ऐसा लिख लूँ 6,000 into 10 power, this will become for me minus 10. And this value will become for me 6,000 angstroms. So that will be the answer for me, 6,000 angstroms. Am I clear?
Yes.
Any doubt in this calculation? Calculation clear है? Done है ना बेटा?
Sir, angstrom यानी 10 आता ना सर 10 power minus 10.
1 angstrom कितना होता है? 1 angstrom is equals to 10 to the power of minus 10 meters.
Yes sir. Approximately sir.
minus 7 आया ना बेटा? तो इसको मैंने क्या किया? minus 3 से ऐड किया और इसको 10 power 3 से ऐड किया. तो 10 power 3 ऐड किया, 10 power minus 3 ऐड किया इसके ऊपर. Divide and multiply by 1000 किया.
हाँ हाँ सर.
क्लियर है ना?
Yes sir.
नेक्स्ट क्वेश्चन बेटा. In a YDSC, a student observes eight fringes in a certain segment of screen. Okay. When a monochromatic light of 600 nanometer wavelength is used. Okay. if the wavelength of light is changed to 400 nanometers, then the number of fringes he would observe in the same region of screen. Same region of screen is कितना होगा? Option is 8, next one is 9, third option is 12, fourth option is 6. First read the question बेटा. Question समझो पहले. In a YDSC experiment, the student observes 8 fringes, यानी 8 fringes, first one, in a certain region, in a certain segment of a screen with a monochromatic light of wavelength कितना? 600 nanometer. 1 nanometer कितना होता है बेटा? 10 power minus 9 meter. 1 angstrom कितना होता है? 10 power minus 10 meters. याद रखो. Wavelength is used. If the wavelength of the light is changed to 400, 600 से 400 को change हुए तो then the number of fringes कितना बोल रहा है? यानी this will be equal to n times of your beta 2 मान के चलो. Isn't it? क्योंकि बीटा का फॉर्मूला क्या है बेटा? बीटा is equals to lambda into capital D divided by small d. अगर वेवलेंथ डिक्रीज होगा तो फ्रिंज विड्थ भी क्या हो जाएगा? डिक्रीज होगा, है कि नहीं?
Yes.
So fringe width will be decreasing. Now we need to calculate the value of your n. तो देखो यहाँ पर बीटा का फॉर्मूला क्या लिख सकता हूँ मैं? 8 into beta 1 will be equal to how much for me? Lambda 1, sorry. This will be lambda 1 into capital D divided by small d. That is equals to n into lambda 2 capital D divided by small d. Small d same रहेगा, same pattern. Capital D capital D also will be changing. So here 8 times of lambda 1 is equals to n times of lambda 2. n निकालना है अपने को. n is equals to lambda 1 divided by lambda 2. That is equals to 8. Lambda 1 कितना दिया था फर्स्ट वन? 600 नैनोमीटर दिया था, divided by lambda 2. Lambda 2 कितना दे रखा है? 400 nanometer. So this one is your 400 nanometer. Nanometer gets cancelled. This 2 0 cancel right now for me. 4 1 जा 4 2 जा 6 2 जा 12. यानी नंबर ऑफ फ्रिंजेस कितने बनेंगे? अगर वेवलेंथ कम हो रहा है तो 12 बनेंगे. Am I clear? एक बार देख लो फिर से. ठीक है ना बेटा?
Yes, sir.
आप इस आपको ओपन करके प्रॉब्लम प्रैक्टिस करना शुरू करें बेटा.
जी सर.
आप ऐप ओपन करके एक बार यू प्लीज ट्राई टू स्टार्ट डूइंग द प्रॉब्लम्स बेटा. ये वाला
वो
जो
कुछ करे तो
लिंक आपको जो मैडम भेज रहे हैं ना, ये वाला इनसाइड मेडेस बोल के है, देखिए इसको आप अगर आप खोलोगे सो यू विल बी गेटिंग. आप नंबर ऑफ प्रॉब्लम्स प्रैक्टिस करने के लिए आराम से यूज कर सकते हो. जैसा मैं अभी लॉग इन हो रहा हूँ वो बता देता हूँ. 700 कुछ कॉस्ट होगा आपको. एक बार पेमेंट करके आप ज्वाइन कर लीजिए और टॉपिक का आपको एग्जाम मिल जाता है आराम से. जैसे मैं टॉपिक पढ़ा दूँ उस टॉपिक पे आप एग्जाम लिख ले सकते हो. जैसा मान के चलो यहाँ पर मैंने देखो नोट्स वगैरह भी रखा हुआ है. ई लाइब्रेरी में नीट फिजिक्स की पीडीएफ वगैरह भी है. टेस्ट सीरीज देखो इतने सारे हैं यहाँ पर. यहाँ पर पेंडिंग फॉर्म
ठीक है सर।
तो एक बार बता ही देता हूँ। तो ये मेडिकल डाल दिया। टॉपिक वाइज टेस्ट है देखो। अब जैसे अपन फिजिक्स में जा रहे हैं, फिजिक्स में 60 टेस्ट है। तो अगर इसमें हम लोग अगर आज का टॉपिक ले ले अपन, दैट इज अबाउट योर वेव ऑप्टिक्स। स्टार्ट द टेस्ट अगर आप करते तो इसमें आपको क्वेश्चंस बनेंगे। दिख रहा है?
जी
ये डायफ्रैक्शन के लिए है। उसके बाद ऐसा फ्रोनोफर अभी अपन नहीं करे। ये यंग्स डबल स्लिट एक्सपेरिमेंट है, देखो ये वाला कर सकते हैं अपन। इन यंग्स डबल स्लिट एक्सपेरिमेंट, मोनोक्रोमैटिक लाइट फ्रिंज पैटर्न शिफ्ट्स बाय सर्टेन डिस्टेंस ऑन द स्क्रीन व्हेन ए माइका शीट, ये भी अपन अभी टॉपिक नहीं हुआ। The wavefront of a light coming from a distant source of an unknown shape are nearly what? It will be your plane wavefront. ऐसा आंसर टिक कर दिया, प्रैक्टिस करते जाओ। Two sources of light are said to be coherent when they have the light of your same wavelength, amplitude, and wavelength and constant phase, and amplitude in different same wavelength and constant phase. उसके बाद ऐसे wavefront is an imaginary surface where the phase is always same for all the points. उसी तरह से नेक्स्ट वन, इनिंग्स डबल स्लिट एक्सपेरिमेंट लैम्डा वन। ऐसे वाले क्वेश्चन आपको मिलते जाएंगे। जैसे आप सबमिट करोगे इसके अंदर, सो विल बी गेटिंग द सॉल्यूशंस फॉर ईच एंड एवरी क्वेश्चन। ठीक है, हम लोग ने
हाँ
आंसर्स नहीं दिया, ऐसा कर दिया तो अपने को देखो हर चीज का फिर अपने को आंसर शो करेगा। फर्स्ट क्वेश्चन का कितने कितने रॉन्ग है, यू कैन री अटेम्प्ट ऑल दैट क्वेश्चंस लाइक प्रवीव सॉल्यूशंस को मारे, इट वाज मीडियम बोल के डाल दो कुछ भी है, देन सेंड फीडबैक कर दिए। देखो फर्स्ट क्वेश्चन का है, आंसर दे रखा है, उसके साथ उसका एक्सप्लेनेशन है। फिर सेकंड क्वेश्चन है, उसका एक्सप्लेनेशन है। फिर थर्ड क्वेश्चन है, फिर उसका एक्सप्लेनेशन है। फिर फोर्थ क्वेश्चन है, फिर उसका एक्सप्लेनेशन है। isn't it like that for all questions you can go and write the solutions also. हार्डली सम 600 या 700 रुपीज है, पूरा 1 ईयर तक आएगा आपको। और यू आर हैविंग एन नंबर ऑफ टेस्ट। जैसे मान के चलो मैं आपको अगर मैं बता दूं, फिजिक्स के अंदर ओवरऑल यू आर हैविंग हाउ मेनी टेस्ट। देखो टॉपिक वाइज अगर टेस्ट ले रहा हूं मैं, आई एम हैविंग ऑलमोस्ट लाइक 60 टेस्ट, केमिस्ट्री में 98 टेस्ट है, बायोलॉजी में 107 टेस्ट है, पार्ट टेस्ट है। अगर आपको मॉक टेस्ट लिखना है तो मॉक टेस्ट भी लिख सकते हो बेटा। यू आर हैविंग एन नंबर ऑफ योर मॉक टेस्ट इन दिस वन। अभी तो 10 डाला है मैंने। इसके बाद सेक्शनल वाइज टेस्ट भी है। फिजिक्स में 3 टेस्ट है, केमिस्ट्री में है, बायोलॉजी में प्रीवियस ईयर्स पेपर्स भी है, और चैप्टर वाइज पीवाईक्यूज भी आप कर ले सकते हो। फिजिक्स के अंदर 21 पार्ट टेस्ट है। और चैप्टर का जैसे वेव ऑप्टिक्स अगर आपको करना है तो वेव ऑप्टिक्स और क्वेश्चंस कर ले सकते हैं। हमें क्लियर? जैसे फर्स्ट ईयर का है, सेकंड ईयर का सवाल। हमें क्लियर?
Yes, sir.
एक बार आप ओपन करके एक बार आप देखो, देन यू विल गेट एन आइडिया।
जी सर।
ठीक है।